Hey guys, welcome to Mrs. K's way of supplementary, complementary, and adjacent angles. A little bit of this is review, but let's start from the beginning just in case we forgot what we learned last year. So you're going to see that we have 4 different topics in this video. The first is we're going to remind ourselves of supplementary angles. The second is we're going to remind ourselves about complementary angles. 3 adjacent angles, and finally we're going to use all the knowledge of 1 through 3 to find the unknown angles. Now, the first thing we need to do is to define supplementary angles. As you have seen this before, supplementary angles are when the sum of the measure between 2 angles is 180 degrees. Now, by looking over here on the right side, we see we have a line, and a line is exactly 180 degrees. So from one point to the next, that whole point is 180 degrees. 180 degrees. Remind yourself of this little degree symbol right there. It looks like a little 0 exponent, but it means the degrees or the angle of the different line. So we see up here that a line is 180 degrees. So if we look at 2 different lines, we can see that 2 of them would create 180 degrees. So let's look at our first example is right here. We see that we have 120 degrees and 80 degrees. Since this right here happens to be a line, we know that the 120 degrees plus 60 degrees will equal 180 degrees. Now, supplementary angles are also nice because they also don't necessarily need to be on the same line in order to know that they're supplementary. So we can see here that our example is we have 2 angles. One is 140 and one is 40. And since 140 plus 40 is 180, we know that these 2 are also supplementary. So we just need to know that it's between 2 angles that is 180 degrees. Now with complementary, it's the same thing as supplementary, except for now we're only finding the sum between 2 angles, which is 90 degrees. So over here we have a right angle, which means that our right or 2 angles together, I can represent it using a little box, but this shows that it is 90 degrees. So if I started right at this point and I opened up all the way to the left, I opened up a total of 90 degrees. Now, if we look at our examples over here, we can see that right here we have 2 different angles, 30 and 60, and if we added those together, we would be able to get 90 degrees so that we know that these both are complementary. Now, in the same way that we saw the supplementary as not having to be connected to each other, it's the same also for complementary, where we also see that these 2 angles, 40 and 50, are complementary because they both add up to 90. Now, I hope you were taking notes on the past 2 vocabulary definitions, and this is an important one as well. Adjacent angles are when 2 angles share a common vertex and a side, but have no common interior points. So if we look at our 2 complementary examples from the previous slide, we want to determine which of these have adjacent angles and which do not. Even though we know that 30 plus 60 and 40 plus 50 give me a complementary angle of 90 degrees, in order to tell if they are adjacent, we have to look for that common vertex and side. So in this first example on the left, we see that both our lines come to a point together. So that is the common vertex that they share. And we also know that they have a side or a ray right here. And remember, a ray is at a point that continues in one direction forever. So because they have a common side and a common vertex, this example right here is adjacent. But if we look at this one over here on the right side, we see that there are actually 2 different vertex. So they do not have the same vertex, nor do they share the same side. Because these 2 are away from each other and there's a space between them, these are not adjacent. So if we look at our example right here, and let me try to see if I can move that up a tiny bit. Whoops, guess not. We see that this example right here are adjacent and complementary, but this example right here is complementary, but they are not adjacent. Now I hope that you can look at these are supplementary examples and you could determine which ones are adjacent and which are not. And if we see right here, our left side, because they share a point right here for the vertex and a side, this 20 and 60 degrees are adjacent and complementary, but right here, because there are two different vertex and even though the sides are going the same way, since they are not shared, then these are not adjacent. So now we can use our understanding of the supplementary, the complementary, and adjacent angles in order to find unknown angles. So for our first example, we know that the measure of PQS, so right here, PQS, that angle and the measure of angle SQR are complementary. So let's try to find the value of that missing X. Since we know that they are complementary, we know that both the 41 degrees and the X are both going to equal 90 degrees. So let's come up with an equation right now. So I know that the angle of 41 plus the missing angle X, since they're complementary, equal 90. Now, my whole goal is to try to find what this missing value of X is. So now I have a one-step equation to be able to find X, because X plus 41 is equal to 90. So if I subtract 41 from both sides, I know that X is equal to 49. So our value of X, so the measure of angle SQR is equal to 49 degrees. Finally, our last example for today, we're trying to find the unknown angle of a supplementary example. So if we know that PQ is a straight line, find the value of X. Well, since PQ is a straight line, we know that both 130 and X should come to a sum of 180 degrees. So this is what our equation will look like. So since my goal is to get X to be by itself, I know that if I'm adding X, I want to subtract 130 from both sides, and I know that X will then result in 50. So then my measure of angle PQR is equal to 50 degrees, because 50 plus 130 will give me a total of 180. And to reward you for all your hard work today with angles, here is a well-deserved picture of my puppy Callie. Can you believe she's almost a year old? Well, can't wait to see what the next photo is going to be, because she'll look even bigger.